Slaven, welcome to the show. Super excited to have you on and talk about the GLAMOS. Let's start off with who you are and what you've built.
Hi Nick, as you said, I'm Slaven. I'm coming from Croatia, from Europe. I'm a founder and the CEO of GLAMOS. GLAMOS is a startup and also named for a tool which you can use for testing your LoRaWAN network, for testing your Helium network. And also we have device GLAMOS Walker, which is most advanced LoRaWAN testing tool you can find in the world. So GLAMOS is like one-time solution which can be used for a long time, but you have everything you need for testing your setup, for testing your antennas, for testing different locations where you want to set up your hotspot, or where you want to set up your sensors. So it allows you to go around, also make coverage mapping to see where network is available. And finally, you can save all data in our application. You can visualize them in map, in table. And also we have now a tool for creating reports after you make all of these testings. My background is electrical engineering, so I'm an electrical engineer. I have 4 years experience with LoRaWAN networks and LoRaWAN systems. I have developed a system for monitoring agriculture fields based on meteo stations and IoT devices. It is called 𝗬𝗓, which was like base, and which from that project I got idea for developing GLAMOS.
Dig it. Okay, so let's see, you came into this, not initially, you didn't come into it through Helium. You were already into LoRaWAN, into long-range wide area networks. You already understood that stuff. And then Helium kind of popped up on your radar. Is that right?
Yeah. Well, I started developing a tool because I needed it for 𝗬𝗓. When we went to some vineyard to set up sensors, to set up devices, we had a problem because 4 years ago when we started using LoRaWAN, network was bad. And so we went to vineyard, you set up sensor and then you don't know, is there some network? How good is that network? Then you need to disassemble everything, reprogram and things like that. So the reason for developing GLAMOS was because of sensor deployment and also testing network. And later Helium came in this story, and now we improved that. We also put more features for Helium network.
Yeah. In fact, let me go grab it. I think so when I first came into Helium, which was my exposure to LoRaWAN. I didn't know much or anything about it before Helium. It was, one of the first questions is, how well is my hotspot going to do? And then the second question is, how well is this antenna going to do? And so just like lots of people, we looked around everywhere. You already had this thing that you developed, but I had I think I ordered one of these guys. Was the very first thing that I ordered. And it's got 2 buttons and an on-off switch on it. And it works okay. But it didn't do what I wanted it to do, which was I wanted to be able to connect it to an antenna. It doesn't do that. The antenna on this thing is permanently attached. So you couldn't test an antenna. You could only do that with the VNA, which just tests kind of very specific things within that antenna, not what it's actually doing. And then all that can do is just send out a beacon. You don't really see what happened other than if you get onto, I think it was mappers.helium.com, like what would happen. So when I saw GLAMOS come out, which I've got right here, here's the base unit, all right? I got one of the red ones, super excited. And then a bunch of the antennas is you can attach any antenna you want. You can take the thing wherever you want. If it's connected to Wi-Fi, you can see what it's actually doing in real time. Did it connect to this gateway or that gateway? So pretty cool tool in the sense of an average Helium user. They're going to use it to test location and antenna. And then eventually probably what the network is actually for, which is whether or not a sensor can connect to a gateway. Did I miss anything big there? There's other stuff out there?
Well, yeah, that's in basic. That's it. This first field tester you showed, Adonis, was our first device we saw that, and that was the only device which can be used for doing testings. But as you said, it lacked a lot of features, but features that you really need with whatever engineer needs. So, for example, if you want to test network with different spreading factors, you cannot set it up, which is really important, and many different things. And we didn't be satisfied with that. So our now list of feature is much longer. We have comparison list where you can see that GLAMOS Walker has really a lot of features that can be useful for doing testings. And yes, as you can see, you can use it for different use cases. Some people need it to make some coverage mapping, so they want to know how far they hotspot or gateway can reach. Some other people want to know, for example, they want to set up some sensor in house. They want to know if there is some signal in their house, or is on left wall signal is better than on right wall, or if do they have signal in basement, or do they have signal at their water meters and things like that. And also now with Helium, people can use it to know can if they buy some hotspot and they want to set it up on some location. So for example, it is a balcony. Before setting up hotspot, they can know, okay, I'll take GLAMOS Walker and I will see can I reach to any other hotspot, or to how many hotspots can I reach. So they don't need to set up hotspot, they don't need to wait and to lose money and lose time and lose energy. They can do that in a couple of minutes, and they can get pretty good results with GLAMOS Walker.
Yeah, no, I think it's great. One thing I noticed last night setting it up is that I'm putting on the little antenna right now, is that this is an SMA connector. It's not an RP SMA. And at least in the US, Helium is using the RP, the reverse polarity SMA connector. So if you get it, you'll probably need to get a cable as well that's got SMA on one side, and then whatever it is that you think your antennas will be.
Yeah, about that, when we started developing device, a lot of gateways or hotspots had this SMA female connector. And when Helium came, most of producers started producing with RP SMA female. And because of that, now we are shipping also RF adapter, which can you plug on device, and then you can plug RP SMA male and also SMA male cables or antennas or whatever else. So before
I ended up getting like a whole adapter kit. So
we have now that also.
That's cool. It's funny talking to engineers, because I think of myself as definitely a non-engineer. Is we think of everything should work just like an iPhone, but an engineer kind of understands what's actually happening and saying like, okay, well, here's why you have this, or why you have that, or why you don't have this or that. So on your end, it must be frustrating sometimes to have to make things so simple for people like me.
Yeah. So I have some vision of using electronics and IoT and implementation and setting up IoT in common. I believe that electronic devices are just a tool to get experience and user experience, customer experience, to get value from these devices, from these tools. So I believe that users need to, they should be allowed to set it up easily, to use it easily. So my idea when I started using that device was, I don't want anyone need to know coding. They don't need to know programming to change some parameters and things like that. And for that purpose, GLAMOS Walker offers setting up all parameters easily just on your device with a few buttons and a screen, so you don't need to know anything. You just plug on device. You have different modes of working for device, so you can just press few things and it will do magic for you. So I believe, and we are doing a lot in that way also with our other product, 𝐻𝐸𝐿, because 𝐻𝐸𝐿 was made for farmers who are not tech savvy, so they should be able to take that device, go to field, plug it on, and just leave it. They don't need to know where to rotate solar panel. They don't need to know how to connect some wires and things like that. So that's our vision and our idea. So everyone can easily use it and without a lot of engineering knowledge.
Yeah, it's pretty cool. I mean, it's not quite total like plug and play, everything works right out of the box, but it's certainly not difficult. And you've done a pretty good job of saying, hey, here's step one, here's step two. You got a couple YouTube videos that walk people through it. And then the other thing to mention is that you've got probably the best customer service I've ever seen. And it seems to be all you. Is that whenever I've had a problem, I write you on Discord and you're like, oh yeah, fix this, fix that. One time you came on and did a screen share. It was, at some point you'll get overwhelmed with all the customers you're going to have. But for right now, it's pretty awesome to have that level of service. So yeah, good job.
Yeah, thank you. We are putting a lot of effort in that part. I believe that customer support is one of the main things, because if we want, we can sell some device, some tool, but it is not good enough, because people want some value. They want some better user experience, and that's we also want that, because if customers are not satisfied, they will not come back, and they will not take some other things we are doing. And we are really putting a lot of energy in developing new things, even more interesting. And our goal is to satisfy everyone and to make them enjoy using our products.
Yeah, no, it's pretty rad. Okay, so let's talk about how someone would use this. There's a whole setup process once you get it. It's pretty straightforward, and I'll put that in a post that I'll write about this to make that easy. Once you've got it set up, you got it in your hand, you turn the thing on, and let's talk through two different goals. The first goal would be testing different antennas. So let's say you've got a low dBi, a high dBi, a mid-gain, a multi-polarized, whatever your antennas are that you're buying. Can you walk me through how someone would test those on the device?
Yeah, so just a few words about first time setting up device. So how this device works is that you have device which is not connected to any network. So it is the same if you buy your smartphone and you have device, but it is not connected to any mobile network. And you buy some SIM card, which allows you to communicate between that your smartphone and some mobile provider. All these devices don't have some SIM card, but it has some keys which are unique for that device. So you need to send these keys to that network provider, and in this case, it is Helium. So if you want to communicate with Helium network, you need to make sure Helium has your keys. So device will send message first time in joining network. Device will send a message. Helium network will see, okay, I have these keys in our database or on our blockchain, and this device is part of our network, and we will confirm him that he can continue communicating with us and sending net messages. So that's how it works, and that's the first time you need to set it up, but it takes just a couple of minutes following all these video tutorials or step-by-step tutorials. And yes, so as you said, you can test different antennas. That's one of the features. So that's pretty easy. Goal of that is you want to know how some antenna perform in some environment. So when you buy some antennas are just passive components. They are a piece of metal that should do something. Antenna should take your signal from a module and make it more powerful, let's say, and emit it in air. So we don't know how some antenna will work in some environments. So for example, you are at balcony, there are walls around you. It is not the same if you set up your antenna at the roof, also if you set up your antenna at the basement. Using this testing tool, you can go to one of these locations, take few different antennas, send messages. So you can just turn on device, join network, attach one antenna, send 10 or 20 messages, attach other antenna, send 10 or 20 messages, etc. And finally, you will get information, okay, this antenna was working like this antenna was working like this, and then you can compare different antennas and you can find which antenna is best fit for your use case.
Interesting. So you're not just doing one. So let's see if I can hold this up, if it can get read. I don't know if that's backwards or not, but so you're not just doing like a send once, you're doing send multi, and you're hitting that send multi multiple times. So let's talk about the difference between send one and send multi, and then how many times you should test an antenna before you feel you have enough data.
So because you are doing testing over the radio frequency spectrum, so it is wireless communication, and that communication is really sensitive. It is sensitive from other signals that are in the air. It is sensitive because of someone is passing by. It is sensitive about weather around and many different things. So when you send one message, it is possible that your message can be a little bit out of some normal range. So why we are using send multi and why we are sending 10 or 20 or even more messages is to get more objective results. So if we send one message, so for example, RSSI can be like -90, but if we send 10 messages, we can see that maybe that signal quality of -90 was just once, and all others were like -110. So this first time gave you some gave you some better results, but that is not objective. So we are looking for something that in some time period, and this time period is like a minute or 2 or 3, gives you more objective, so you know, okay, this is average. We don't looking for these edge cases. We are looking for some middle case, some average, and that helps us. And you can do that analytics manually. So when you send all this data, you can go to our application, and then you can check, okay, my RSSI was this, and then you can write some notes or whatever you need to make analytics. But we developed this analytics tool, which helps you to make few clicks in our application, and you get complete report about how many messages you sent, how many antennas did you test, and what were the results. And inside of these results, then you can have some statistics, and you will see, okay, average RSSI for each of antennas were this. Then we can compare, okay, this antenna had the best average RSSI, but we saw that it is not good enough. So we also, because sometimes we have big oscillations, and that's what was I talking, that sometimes something happen in the air and that affect your signal. For that reason, we put also median, that is other statistic, but it doesn't sum all these signal numbers and then divide it with number. It takes whole range of devices and finds some middle index of that range. So that tells you, for example, if you have -10, then you have 10 times -90, that your average probably will be -70, -80, but you see that 8 of 10 times you had -90, and that is median, and that is real value. So using median, we want to cut out some mistakes that can happen during your testing. And based on that results, you can decide which antenna is the best. You have really long list of parameters which can help you to decide that. And after all of these things, you have more data in our tool, which can help you to analyze, okay, I know that there is some hotspot in my neighborhood. I want to see how each of these antennas perform with connection with that hotspot, or with some specific hotspot, or with some hotspots in some area. And that will help you also to analyze, okay, I want to reach that area and I want to focus on that. And you can do testing also based on that. And you can see graphs and many other things.
Cool. So when you're testing an antenna or a location, would you say that the minimum number of times you would do it is 20? And then is there a time interval between those? So like you test, wait a minute, test, wait a minute, or is it more like test, wait 10 minutes, or do you test 4 times throughout the day? Like what would be the protocols that you would set so that you felt you had good information?
Yeah, when I'm doing testings, I use like sending 20 messages. Even sending 10 messages is pretty good. We can show later how it looks like one of testings we did, because when you take a look on your graph, you will see that there are some oscillations, but in 10 messages, you can get pretty the same results as in 20 messages. So average RSSI and things like that will be pretty the same, but a bigger sample is better because then you can get really better results. So I'm using like 20 messages 2 times, sending 10 messages. I don't make any pause, so I wait sending 10 messages, and when I see that it is finished, I just repeat that process.
Got it. Okay, so no pausing at all. And when you're saying that you're sending multiple messages, it's you're hitting this whatever. Is this backwards for you?
What?
Do the words look backwards for you?
No, that it is okay. It is from left to right.
Yeah. So let's see the select button here. So you're doing that. You're hitting that send button. Let's say 10 times. So you'll go through and hit SF10, and you'll go to join. So it'll look like, let's see, that, and then you'll just hit the whatever button, and it's firing it out right now. And we'll see, maybe it'll show up in the app, and then it'll say whether or not it goes through. So you're doing that whole process 10 actual times. So you're going back and saying like, all right, I'm going to hit this button again until.
So you don't need to do that. And to make it easier, we were thinking about that, and to make it easier for customers. So in send multi-mode, you have a same SF loop, and there you can set up to 10 times repeating. You can set up spreading factor you need and click send. So device.
Oh, really? Okay,
yes,
I didn't realize that.
Yes. So device will send.
If you're single, it just sends the one time. So it's like join successful. Great job.
First time you need to make join using send once, and after that you need to go to send multi. You have there send with loop, and then you can set up repeat 10 times. So device will send 10 messages in a row, and
So you're going down to the same SF loop thing.
Yes.
Yeah. And then, okay, cool. And it says repeat whatever, 5 times or 10 times or 20. So you'll turn the repeat to 10 times or 20 times, sorry.
Currently maximum is 10, so you need to repeat sending 2 times.
Okay. Got it. All right. So I'll just see if I can do that on the screen. Let's see. There it is. Repeat. And you go into it, and then you're going up till 10. Whoops. Yep. And then hitting select on that, and you're done. Okay. Awesome, dude. Super cool. Okay. So you just do that twice, and you're not worried about a time interval. Would you test that in the morning, in the evening, or is that a little bit too much information or kind of too geeky?
Yeah. So as I'm an engineer and have a lot of experience with that, I saw that there is difference with doing these testings. So for example, we have set up our metal station to highest mountain peak in Croatia. It was -10 today, I think. And we were able to reach to hotspots that were 300 or 350 kilometers away on Italy coast. And that is pretty great. And just on spreading factor 9. And that's really impressive. But we also saw that sometimes we can see these hotspots and sometimes we cannot see these hotspots. So that was really interesting for me. So I wanted to see why is that happening. And what I figure out that humidity in the air can affect signal a lot. So when there are clouds, when it is foggy time and a lot of humidity in air, signal quality will decrease. Also, from some other use cases, I know that in urban area, when a lot of people are going around, a lot of cars, a lot of movement, also signal is a little bit decreased. So because there is more noise in the air, more signals in the air and things like that. So in urban area, during the day signal is worse. If you are doing testings, probably you want to know what is the worst case. And for that reason, probably you want to test it maybe during the some of these. But if you are not too geeky, that's maybe not necessary to do because difference will not be huge. So you will not feel that. And as I said, we are doing testing for worst case, and we are expecting that in future we will get some better results.
Got it. Okay. So just kind of general idea is that you want to test everything that you're testing, whether it's a location or an antenna or a connection to a sensor, with at least 20 sets of packets, right? 20 transmissions. Is that correct?
Yes, you're correct.
Okay, cool. So that's helpful, and that can be done in 2 batches of 10. So it's reasonably quick, right? You send your first batch of 10, maybe wait a minute, send your second batch of 10. If you want to be ultra geeky, you do that once in the middle of the day and once in the late evening where it's a little bit clearer and colder, and see what's going on. Okay.
And one more thing I want to mention that is really important is because this device can be carried around. So you can take your device, you can attach your antenna, and you can go around. But what is important during the testing is to try to hold device steady. Why is that? Because if you, I'm not sure where is my antenna now. So if you make some angle, signal is propagating like around omnidirectional around antenna. So if you, for example, put device on some angle, signal will not go horizontally, it will go like this. So for example, if some hotspots are at lower height, you will have better signal. If some other are on the higher height, you will have better signal there, but in horizontal, you will not have good results. So idea is to try to put device or something steady or make your hand as steady as possible. So because if you are shaking a lot, especially if you are holding bigger antennas, if you are shaking a lot, you will get worse signal, you will get worse results of your SNR, signal to noise ratio, and things like that.
Okay, cool. I'll keep that in mind. I set up a little test rig on my roof, so it's a stand and a pole. You put the antenna on the stand, and then you've got the little device, whatever, at 5 feet down. I think the other thing that you could test, and BFG Neil talked about this in a recent interview we did, was you can test different cable lengths. So you can test 2 feet versus 5 feet versus 20 feet versus 100 feet of LMR 400. I mean, you're an engineer. This is your thing. If you're giving advice to people who are setting up hotspots, what are some basic rules of thumb that you give them? Are you always saying LMR 400 in less than 10 feet? Or what do you typically tell people as a good start point?
Well, there is no perfect setup. There is no perfect installation. Only perfect. Yeah, there is perfect. If you take your hotspot and connect your antenna directly to your hotspot, so no cables at all. But in most cases, we know that is not possible because of some normal reasons. There are some technical characteristics of each cable and of each antenna which affect signal quality, but that is not so important. So if you set up, for example, you set LMR 400 or LMR 240, there is difference. We can put it in calculator, but we will see that on some smaller lengths of cable, it will not affect signal quality a lot. We will have some loss, but not too much. What I recommend definitely is to not put long cables. You need to make it as short as you can. So it is better to put your hotspot box, so you device your hotspot, as high as you can, and then take some power cable and internet cable and put them like 100 meters, then put like 5 or 10 meters of cable. So in terms of that, not just because of cable quality, some things around the cable can affect. So it is not the same how metal will work on like -10 and +40 Celsius degrees and things like that. So there are a few things. Make cable and connection as short as possible. It is better to put a hotspot somewhere outside and put a longer power cable, and that's something that can give you the best results.
Dig it. Love it. Let's do a little stuff on the app now. I've got it pulled up. I'm going to share my screen if that's cool with you. And we'll take a look at what I've got. So here's my GLAMOS app. Here's the GKI thing. And you can see we got the GLAMOS. I got that thing in there. You had helped me get that in there a while ago. I just hit that SF thing. I'm not sure if this table is pulling off of that, but do you want to talk me through how you guys developed this and what you guys are looking for and how you might use it?
Yeah, so how development was going is that first, and the most important thing is to get your data from Helium network to our application, because of that you need to make this first setup where you make integration from Helium network to our application. That allows you to, every time you send message from your device, Helium network will transfer a message to our application. All messages that you created with your device are stored in your table. So what you are showing now are all messages you were sending in your past, and you can see that you can see their time of sending and some other parameters which are important. If you click on that arrow at the beginning of the row, you can get information about all hotspots that reached from location you were testing. So for this message you are showing currently, we see that this time device reached to 4 different hotspots, and the best one was this sweet sage pike, which is 10 meters from you currently, and
it's right up on the roof. Yeah, that's my home hotspot.
And further is 27 kilometers from you. So these are some things that are really important. We can see currently that your device have GPS coordinates. It is sent, and you are doing testing with antenna type 3. So that allows you to know what settings did you set during the testing. So for example, if you go to field, to your roof, you take your device, you set up in a menu antenna type 3, and that is just like name of antenna. So it is not something that will affect if you put this or that number. It is just like name. So when you see number 3 in table, you will know, okay, I decided that my antenna XY will be number 3, and some other antenna will be number 4, and things like that. And
Got it.
these parameters like counters, so each time device join network, it will reset counter, so it is parameter which will increase every time you send message after joining network. Frequency on or channel on which device is sending. The device is sending on 8 different channels or 8 different frequencies. And the spreading factor is parameter which affect modulation. So that is how device will create your signal physically. So device, we see some data on screen of device, and then device need to transfer that in a real signal, radio frequency signal that are electromagnetic waves, and this spreading factor will decide some things, how it will modulate this signal, and then how hotspot will receive that and then modulate that. And these bandwidth and coding rate are some additional parameters. In table,
you can filter it however you want. So you can, I only want a CSF8 or what, et cetera, et cetera.
Yeah, you can analyze, you can filter data based on antenna. You can filter them based on your some specific hotspot. And if you have more devices, you can also filter data on some specific device.
Oh, okay. So on this gateway thing, and this is kind of an engineer to helium translation, is that technically what a helium person would call a hotspot is actually a gateway.
Yeah. So in LoRaWAN world, in most servers, hotspot is called gateway. So because of that, we have in our application gateway and not hotspots, but hotspot equals gateway.
Got it. And then let's see, can I name my antennas different things, or I just have to keep track that, type 3 is the short one and type 1 is the whatever is
currently,
et cetera, et cetera?
Yeah, currently we don't have that, but in near future we will add also that feature so you can set up your own names.
Okay. And then the time, this must be GMT, right? This is
not sure.
Or is this local?
It should be your time how your browser sees that, but
oh no, this was last night. Yeah, I was testing this out last night. That's right. Okay, cool. Because it's 11:29.
Maybe you didn't send any message from device. You did join, but you did not send any message currently during the live.
Okay, the one we just did. Yeah. Okay, cool. So we got the table, we got the map.
Yeah, map is one of things that we are really proud of. It has really nice features. So these blue rectangles are all hotspots in some area. We got question why we need to create servers, why we need to add gateways. Reason is just because of better user experience. So if we need to load like 300,000 hotspots, it will take a lot of time to show it to you. But with if you can set it up like in your area or something, whatever you want, and that will allow you to load your map and the table and everything much faster. So it is just because of better user experience. And
that makes sense.
you can see these blue rectangles, and if you zoom where this red dot is, that red dot is the last measurement. And if there are some other, if you zoom more under that red dot, you will see different colored points. So these are points that you sent from your device in past. And if you zoom out or press that minimize icon, you will see a red line. So this device so you communicated from that point with some hotspots that is connected with this red line.
Okay, very cool.
And if you click on, for example, on some hotspot, you can click on this that is connected. Click on receive signals. Yeah. And you will get all lines from which hotspot received message. So, for example, if you want to test some hotspot in some area, you can go around in your neighborhood, send messages go home, click on this, and you will see lines all around from which that hotspot received message. And that way you can see also later, okay, my hotspot can receive messages 300 degrees around, or maybe my hotspot is not receiving messages from one part of city, so maybe I need to adjust my setup to move antennas somewhere else, or maybe I'm satisfied with that. So for example, as you can see, that point communicated with these hotspots.
Okay, cool. So this is kind of like the witness lines, although I'm not seeing as many. This is only happening, and this is because I only have used this thing a couple times.
Yeah,
if I use this a bunch, and
yeah, maybe you did not set up multiple packets in Helium console to all. Maybe you limited that to some smaller number, and because of that, you cannot see more than this. And lately, in last almost 2 months, Helium has some problems. If you want to get all hotspots in your area, you need to set up to unconfirmed in parameters. So that will allow you to get them all.
Got it. All right. So I'll go into parameters, and then that's down to confirmed, select. So it looks like, let's see that.
Yeah.
And then it'll be unconfirmed and select that. All right.
Yeah. The difference is just that with confirmed, device send message and it asks network or hotspot to confirm that message is received, and then hotspot need to use radio frequency spectrum to confirm. So it is like sending 2 messages, but it will cost you just once. And with unconfirmed, device will just ping hotspot, and device will forget about that message.
Okay. Yeah. Cool. What's the cost of using this thing in data credits? I mean, I'm assuming it's tiny, but
yeah. So for $10, you can get 1 million of data credits. So you can send like 1 million messages. Or if you are using these multi packets, it is a bit smaller number, but for $10, I think it will take like 1 year if you are doing it regularly. So as I said, when you register to Helium console, you will get 10,000 data credits, and even that is hard to spend. So 1 million for $10 is really not a big cost.
Yep. No, easy stuff. All right. So
and also in map, just one more thing. In layers on right side there are icons. So in layers, click on you see heat map. So click on resolution 7, for example.
Okay, cool.
Then when you make your coverage mapping or testing outdoor, you can see what area you covered and what area can have a better signal, or what can you improve. Also, one more thing which is, I think, really great is a line of sight tool. So in layers, just turn to 3D buildings and
let's see, 3D buildings.
Yeah, you can turn off heat map.
Okay.
And zoom in until you see 3D buildings on map. Okay.
And can you tilt it?
Now go to take line of sight tool. It is under layers.
Yeah.
And click on 2 points.
Okay, so you go from here to wherever.
But zoom until you see buildings.
Oh, zoom until you see buildings. Okay.
You can use it even with not zooming. But as you can maybe see here, or make it again, so turn off and turn on line of sight tool.
Okay.
Now do it again.
Yeah. And so you're going from like here to wherever to over here.
And as you can see here on graph, there are not just line of sight with hills like geography, but also we have buildings inside. We are only one provider who can offer you this, and this is free feature for everyone. So if you not have device, you can also register and use it. So you can see if you use regular line of sight tool, you will see, okay, I just need to put my antenna a bit higher and I will go above this hill. But with this, you see there is some high building on left side, which is much higher than a hill. So maybe you need to increase height of your antennas much more than you expected. So
yeah. Oh, that's cool. That's very cool. All right. It's not showing the 3D layer yet, but that's not super important for this. Okay, cool. Very cool, dude. Neat. Anything else on map that I should look at?
That's it, I think.
Okay, and this just rotates it back to north is up. Dig it. Analytics, the beta stuff. What do we got here?
Yeah, that's also one new tool we just released. We released part of it, so it is still in the beta phase. So it is a tool which allows you to analyze all data. So you have all data in your table, and you can go step by step, click on that arrow, check what hotspot received your message, what was signal quality and things like that, and find the results. But using this tool, you can get a report pretty quickly, like in seconds, and it can give you really a lot of information about your testing. So, for example, you get overview, which tells you, okay, this is the some overview. You did testing with 2 antennas on 2 locations. You are sending 23 messages and reaching to 20 different hotspots. And at the bottom it says you what is the best antenna. Currently, you don't have maybe huge setup. No,
I was doing this like last night. I was just like, how does this thing work? I better have at least used this thing a couple times because it's been a month or two.
Yeah, so, and when you go to other tab, and you can go to next, antenna comparison.
Yep.
You have some graph here, so you don't have a lot of messages, you don't have a lot of these antennas. So if you have more, you will find out, or I can share my screen to show how this drop down menu will work. And under this, okay, I can do it now.
Yeah, if you want to share it, for sure. Oh, this is pretty cool. This is way deeper than I thought. I'd only just kind of bang some buttons and put it onto one antenna, but I'm digging. I've got a whole plan for this. This thing is to test. I got like a layered 6 dBi. I got the H antenna. I got a Nearson 9. I got the rack. I got some eBay antenna. I got these little ones. It's gonna be cool to put it all together.
Yeah. So currently it is in beta phase, so it is free for everyone, but we will see, will it stay like that in future? It will be probably something like tokens or things like that, but it will not cost too much. So as you can see, we have currently enabled just antenna testing, but soon we will release this location testing and coverage mapping. So I'll show you antenna testing, and you can do same with testing different locations to find the best fit. So I put some period, and as you can see here, we did testing with 6 different antennas on same location. We sent 150 messages and reached 195 gateways. As you can see, there is type 4, which is the best antenna. So when we go to antenna comparison tab, you can see here this table with information about different antennas, and this allows you to compare antennas just based on some statistic. And here in graph you can see how it looks like when you set up when you take whole sample of your data. But I'll show you why this is like important to know what is the best. We have 6 different antennas, and as we can see, this antenna type 4 has the most green parts. But as you can see here, for average RSSI, there are 3 antennas that are the same. But what is the point? Point is that these antenna 3 and 5 reached in average to 159 or 56 hotspots. So, and this antenna 4 almost 200. We know that antenna 4 reached to all hotspots, the same hotspots as 3 and 5, but also it reached to additional 40 hotspots. But these 40 hotspots additional, they probably had a lower signal quality. So this antenna picked them up, and it is not objective to compare something where we, in average, got some worse results. So as you can see here now in graph, they are pretty the same. So if we hover to some of these antennas, we can see they are the same. But if we reduce to, for example, the best 101 hotspots per each message, we can see now a difference. So these results are more objective. So for example, this antenna type 0 or for antenna type 2 reached to, in average, 95 hotspots. So it is almost the same position for antenna type 2, 3, 4, and 5. All of them reached more than 100 hotspots, and then we can compare what is the best. Then we can see that antenna 4 is much better than all others. We can see that its signal is much better. Also for antenna 3 and 5, we can see they are pretty the same. So we can see their lines are almost one over the other. And antenna 2 is a bit worse, and also antenna 2 and antenna 0, but antenna 0 has more oscillation in its measurements. And this antenna 1 is the worst. So this allows us to take the best from all of these data. If we take just 3 gateways, so how it works, we send message, 100 hotspots receive our message. So we will take just now 3 the best gateways. So 3 gateways, 3 hotspots with best signal, and we will take their RSSI number, and we will calculate average from that, and it will be showed here. If we take, for example, first the best 50, then we will get some other calculation and we can see it more. So idea is also to put all important parameters at the same starting position. And starting position in this situation is that let's compare antennas if they can reach the same number of hotspots. And that will allow us, okay, this antenna is better in same situation. And you have some other parameters, like we have some counting of giving some points. So you can find some information about that here. And finally, you can analyze by each gateway. So if you click on some of these names, you will get graph which will tell you how each antenna communicated with that specific hotspot, or you will get also for each antenna how each antenna communicated to every other hotspot. So for example, we can see that for some specific hotspot, ambitious 𝐁𝐵𝐴 antenna 4 was the best. Antenna 3 and antenna 5 are pretty the same, so they are mixed up here. But definitely antenna 1 is the worst. So it had continuous signal quality, but it is pretty low. And also here in table, then you can compare for antenna 1. Antenna 1 reached to all of these hotspots, and for that hotspot, average RSSI was this, and oscillation was +2, -1, and things like that. So this tool can be great for beginners. So they can take just overview. They will get information what is the best antenna. They will get some information like how many hotspots they can reach, or that means how many hotspots they can witness. So if they have set up a hotspot on that location from which they are doing testing, they will know, okay, I will be able to reach 195 hotspots in total, or 83 hotspots in average for each transmission. And also they can check in graph and see, okay, they can see different colors and find, so the much higher the one is, higher it is, the better. So
right. Now, when they're looking at that one, I think you've done a post recently saying like, hey, it doesn't, let's see, first, you're making, I think we're making the assumption that a witness and a beacon, or a transmit and receive, are basically the same thing, because it's more or less bidirectional. So if they can hear you, you should be able to hear them. That's an assumption, or that we actually tested?
That is not correct. But unfortunately, we cannot test both sides correctly. We can with using this confirmed setting, but unfortunately, because of helium issues, we cannot do that currently. Why is that? So if you have, for example, antenna which is like people like to use as big as much antenna. So if you take some of 8 dBi, which is like 120 centimeters long, that antenna will be much bigger than antenna like 4 dBi, which is 50 centimeter long. And as we can see physically, this antenna have a bigger metal part which can collect informations. So bigger antennas can collect and can witness probably more hotspots. But the bad side of using bigger antenna is that it had smaller angle of dissipation of signal around. So if you take, for example, this 4 dBi antenna, it will be able, for example, to make like angle of 90 degrees. And if we have 8 dBi antenna, it will be like maybe 30 degrees angle of sending, of beaconing. So idea is to find the best fit between these. Of course, we need to have enough witnesses when we are doing beaconing, but if we set up most of these antennas, they will be also probably it can be possible to do communication on opposite side. And that's few parts. So setting up antennas and all this setup is not just like, let's put it, if you set it up on a balcony, your signal will be probably maybe worse, because there are some buildings around, so signal will not come to antenna. But when you are sending, there is more power for signal to go around these buildings and things like that. So some of these things, and that is the reason why that is the reason why we are doing testings. We want to send messages from different locations and to find what is the best. And for example, we can do testing from our location, but we can go to some other location where we know there are hotspots in some area, and then do testing from street. So you can make coverage mapping and see, okay, I can reach hotspots that are in my area, in my neighborhood, or I cannot reach. So you need then to think more about using this tool, using this device. Definitely can give you a lot of value in terms of knowing how your antenna will work in some specific situations.
Yeah, no, I love it. This thing's awesome. Super, super cool. Let's see, I got a question on Twitter. Is there an open source version of this?
Yeah, currently no, but we will see in the near future. Maybe that will be changed.
Sure, and there's some things you can do. You can build, I've got one right here. You can build like a little mapper. This doesn't do the same thing, but it'll map out network coverage. So I think with the way I look at this stuff is look, if you're serious about hotspot installation and you're serious about doing a good job, you're going to spend whatever this is, $300-500, whatever it is right now to get it in there. And that pays for itself as far as I'm concerned. If you want to do super open source stuff and keep it pretty cheap, that's fine. You can do that, but it may just be more difficult to get where you want to go. That's how I see it. I'm not sure if you see it.
Yeah, so, well, we were thinking about that also. Currently, it is not in our main focus. Currently,
Right.
our goal is to fulfill our current customers and users of these devices. Our devices are currently in usage in 32 countries in the world, so on 5 continents. So it is worldwide, and we have some obligation to our customers to keep developing and giving them value for they paid. So when someone told us it can be true that our devices may be a bit more expensive than some other devices, but when you put everything on table, for money you are paying, the value is much more than you are getting with any other tool. So, for example, as you can say, that small mappers you can build yourself, or I'm not sure, 𝐷𝐷𝐴 or something like that. It will cost you maybe less money, but it will be again almost $100, or with everything, with mistakes and everything. But when you take in account that our application is free for 12 months for storing data and everything, that you get a much better user experience, so you don't need to try different codes and programming and everything. If you take in account that you don't need to know a lot about programming, it will not take a lot of time to figuring out will electronics work or it will not, and many other things. You get package with different antennas for your testing. So
you get this whole thing right here.
Yes. So
look, it's super nice inside. It's a nice layout. There's a couple antennas. Totally worth it. If I lost mine, I'd just buy one again.
Yes.
Totally worth it. Let's see. Go ahead.
So just wanted to say, it is hard to fight with some producers of bigger who can produce like thousands of pieces of hardware, but they give you just piece of component, nothing more than that. But we are giving a real user experience, our knowledge, our experience. So as you can see, this tool is created and based mostly on our experience from real testings and from 4 years experience using LoRaWAN for setting up sensors and many different things. So
no, it's awesome. It's awesome. I think if you've got any hotspots and you've got any questions about them, this is probably, if you wanted to buy just one tool, this is probably the tool to buy. Let's see what I got 2 more questions and we'll wrap up. I know we got time here. I think we got time. What's the most common problem you see people having, either with the GLAMOS or with their kind of hotspot deployment and understanding how to do a good job?
Well, people don't like to read instructions. They don't like to learn a lot. We have some manuals for setting up with some basic keywords, what are important, what is LoRa, what is LoRaWAN, what is spreading factor, and things like that. People often skip that, and then they have problem with some gaps using antennas and things like that. We didn't have time to make more detailed tutorials, but we are working on that. We just published a tutorial how to make antenna testings with this tool and our device. And the biggest problem is that people don't have knowledge about antennas, about radio frequency and things like that. So they are looking for some knowledge in Facebook groups, on Discord. They are making mistakes and things like that. That is the biggest problem I think they are facing with using GLAMOS. As I said, everybody are not reading everything, and that's maybe even our fault, but we will fix that because we will create some video tutorials about IoT, about LoRaWAN networks, about sensors, and that will be probably done during the December. So we will help them to.
Yeah, no, I'm guilty of that too. I know I've asked you something on Discord, and then I read about it. 10 minutes later, I'm like, damn it, I should have just read the instructions.
Yeah,
So,
yeah. So I know that everybody are busy doing their daily jobs. So we will make some short videos where you will be able to, like, in 1 minute maybe or 2 minutes to learn some things, some lessons. So you can take a look every day, maybe a new video, and to learn something more about radio frequency, about LoRaWAN sensors, Helium network, and all other things.
Yeah, very cool. All right, last question. What are you guys, or what are you super excited that you're working on? Like, what's the next thing that you're like, dude, this is going to be so cool when it comes out?
Yeah, so next thing we'll be releasing this location testing tool. So it will be similar to antenna testing tool, just for location. So you take one antenna and go to a few different locations: balcony, roof, basement, your indoor, outdoor, and you can find out, okay, this location is best, or this location is not the best. Or for example, inside of one room, you want to test location one in one corner, another location another corner, and find that out. That will be pretty useful, I think. But one of the things that I'm really excited, and we are working on that already, is indoor mapping tool. So that will be a really great tool. You cannot find that anywhere in the world currently. We will be the first one where you will be able to draw your house floor plan, ground plane. Yep. So you can draw your rooms and everything. You can go in your house where you want, make testings, send messages, and you will be able to get heat map of your house, but not just like one box with different colors, but really beautiful heat map. So you can know, okay, in this room I have better signal, in this room I don't have signal at all. So it will be really great, especially for guys who will want to set up some sensors to their houses and homes and buildings and things like that.
Yeah, that's super. So that's LoRaWAN only. That's not Wi-Fi or 5G or anything.
So
that's just the.
We are, as you can see, we are working on some things that are maybe little bit different or little bit even more innovative than you can find on the market. So this GLAMOS Walker device, it is most advanced testing tool you can find on the market. There's any device in the world that can that have all these features and that can do all these things. Also, our application is currently, I think, the best for testing LoRaWAN networks with a map, with tables, with analytics tools and everything. So that's our goal to create one place solution for everything. And also, as we already also have dashboard, IoT dashboard for getting all data from sensors to one place. We developed that for 𝐸𝐴GR. So if you have some different sensors, you want to collect all data at one place, you can do that. You can see it on graph, in widgets, also store it in table, download it. You can set up different alarms. So for example, you put alarm if my water is leaking, please send me a message. Sure. And things like that. So that will be probably also joined together. So I think we will have one place solution for everyone who wants to work with LoRaWAN networks and with IoT.
That is radical. Super cool, man. Ripping. Slaven, thanks a ton for your time, man. I'll put links to all the stuff that you mentioned at the bottom of this. And yeah, if people want to get a GLAMOS, I'll put a link to that as well. But heck yeah, I think this is a super cool tool. It's an exciting thing on kind of the hardware side, like having something in your hand, and also on the software side. So thank you for your time and sharing with us how the whole thing works.
Thank you for your time. Thank you for kind words, and I hope you will enjoy using GLAMOS even more.